To start out chapter 2 and 3, we first want to look at the idea of matter. What is the basic principles? What makes up matter? How do we define matter? What are the basic concepts that we need to understand when we're looking at matter? Chapters 2 and 3 of this course will look at the idea of what matter is, what it's composed of, the types of matter, what happens when we have a mixture and the types of mixtures, the types of changes that can happen to matter, and how we separate mixtures. Then we'll get into some early atomic theory and learn basic ideas of how the atom is structured, how that theory was developed, and then get into the periodic table. Basic definition of matter is anything that takes up space and has volume, therefore has a density. It's going to have some sort of mass, have to have some sort of volume, so it will have a density. Remember, density is mass divided by volume. For examples of matter, you can think of anything from the chair you're currently sitting in, to the air that you breathe, to the computer that you're watching this video on. All of it is matter. It is all made up of items that take up space and have volume. When we think of matter, we generally break that down into two categories. Those categories of individual types of matter are elements and compounds, and then we get into mixtures of those compounds or elements. Let's start with compounds. Compounds are composed of two or more different atoms that are bonded together in some way. We can think of bond some way as being held together, like glued together. The simplest unit of a compound is known as a molecule. Some examples of compounds are things like water. Pure water, H2O, is the combination of hydrogen atoms and oxygen atoms. Two hydrogen atoms bonded to one oxygen atom. Carbon dioxide, CO2, is a compound. Carbon bonded to two oxygen atoms. So those are just two basic examples, but there are thousands and millions of other ones that we could think of. The simplest unit of a compound is known as a molecule. So we can have an individual water molecule, one oxygen bonded to two hydrogens, or one carbon dioxide molecule, one carbon bonded to two oxygens. Elements are the simplest type of matter in that they only have one unique type of atom. The atom is our simplest unit of an element, except for the case of diatomics, which we'll talk about in a minute. But if you think of your elements and all the elements listed on the periodic table, the elements that we know, these are made up of individual atoms, or diatomic molecules, in the case of 7 of them, and those individual elements can make up compounds. All compounds are going to be made up of elements, but elements will be our simplest unit. You can't break down any further than that element concept without getting into the subatomic particles. Here are some other examples to look at. Here we see that the types of elements involved can lead to dramatically different compounds depending on the ratio of those elements. For example, if you put carbon and oxygen together, if you put a single carbon with a single oxygen, you get carbon monoxide. It's a compound, the individual molecule, CO. It's a poisonous gas that takes the place of oxygen in your hemoglobin and therefore can make it impossible for you to get oxygen into your bloodstream. Carbon dioxide, carbon with 2 oxygens, is a compound we breathe out all the time and we breathe in. It is not, it's a waste material that we see that plants use this waste material to produce oxygen. It is not a poisonous gas to us. Another common example, hydrogen and oxygen. If you put 2 hydrogens with an oxygen, you get water, which is one of the most important compounds that we have in our entire life, something that we are primarily composed of. If you add it, instead make it a ratio of 2 to 2, 2 hydrogens to 2 oxygens, you get hydrogen peroxide. Hydrogen peroxide is very different than water and would be used to disinfect cloths, bleach hair. It's not something you'd want to drink. I said earlier that there were 7 elements that exist as what are known as diatomics. Diatomics means they have 2 atoms when they're in their basic state. Those 7 diatomics: hydrogen, oxygen, nitrogen, fluorine, bromine, iodine, and chlorine. You have to have these 7 memorized. This is a very important list and a very easy mistake to make. These are the 7 elements that exist as molecules, not individual atoms, when they're by themselves. It's always a pair of 2. So for hydrogen, you would get the actual molecule that's formed is H2, oxygen O2, nitrogen N2, fluorine F2, bromine Br2, iodine I2, chlorine Cl2. These 7 diatomics exist as pairs of 2 atoms bonded together when they're in their basic elemental state. They can bond to other things, like you get H2O. You don't have to have 2 H's to make H2O. But if you just see hydrogen by itself, it will always be H2. One way that people commonly think of to remember these is the word mnemonic Hofbrinkel. If you think of Hofbrinkel, that is your 7 diatomic elements: hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. You can also think of them as being that inverted L on the periodic table. So if you look at the periodic table, on the far right-hand side, you'll see nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and then you've got the other one over here on the far left, usually hydrogen. So if you want to think of it on the periodic table, it's usually that upside down L. But Hofbrinkel is one thing I've known a lot of people to memorize this with. Whenever we think of atoms, molecules, elements, compounds, we generally come up with models to describe that. There are various ways to illustrate this. Sometimes you use circles, balls, letters, a combination of these to think of a compound. So let's think of the basic example, water. Water is the compound, H2O. If we were to draw this out, we might draw it with the circle diagram that we saw earlier, where this is our oxygen, this is our hydrogen. We might draw it what's known as a ball and stick model. Oxygen, hydrogen, hydrogen. You might just have the letters, known as what is known as a Lewis dot structure, which we'll see later in the course, with the electrons. We'll talk about that one later. But all of these are ways of modeling this. These are all individual molecules of water. If you take one of the diatomic elements, let's say hydrogen, you might see that drawn this way or this way. For example, this way. Individual molecule of hydrogen. Now, when we think about matter, matter generally exists in one of 3 states: solids, liquids, or gases. The difference between solids and liquids and gas are some obvious things on a macro scale level that we see, and then some things on a micro scale level where we actually look at the individual atoms. If you think of a solid has a fixed shape and fixed volume. It doesn't matter what container you put it in, it always has the same shape, same volume. It's not going to change shape or volume depending on the container you put it in. If you take a solid and you put it in a beaker, a flask, a graduated cylinder, it's always going to have the same shape, same volume. Liquids are a little different in that they still have a fixed volume like a solid, but they take the shape of whatever container they're in. Think about liquid water. If you put it in a graduated cylinder, it'll take the shape of the cylinder. If you put it in a beaker, it'll take the shape of the beaker. If you pour it on the table, it'll take the shape of the table. It'll still have the same volume, but it'll take whatever shape of whatever container it's located in. Gases are different than this in that they take the shape and volume of whatever container they're in. They will spread out to fill up whatever container they're in and take the shape and volume of that container. On a micro scale level, when we're thinking of the individual atoms and molecules, the solid is going to be held in place. Molecules are going to be held together by what are known as intermolecular forces, and those individual atoms or molecules will be vibrating but will not move relative to one another. Liquid spreads those molecules or atoms out a little bit further. They are still held together but not nearly as strongly, and they are a little bit more free to move, but they're still held very close together. If solid was held touching each other almost, it wouldn't actually be touching, but relatively close. A liquid might be just a little bit further apart. For a gas, now the particles are spreading out as far as they possibly can and are free to move irregardless of the other molecules. That wraps up our beginning introduction to matter. You should know the 3 states of matter: solids, liquids, and gas, and the difference between elements and compounds, atoms, and molecules. And also, it's a good time to start memorizing these 7 diatomics.